Welcome to the deep dive. We're here to unravel some, well, really fascinating mathematical ideas, and today we're jumping into a specific sequence for you number theory students out there, OEIS A000294. It's listed as Partitions and Related Series in the online Encyclopedia of Integer Sequences, the one by N.J.A. Sloan.
Oh.
Just to give you a feel for it, the sequence starts 1, 1, 4, 10, 26, 59. Seems simple enough, right?
Well, yes, but those numbers, they hold quite a bit more. What's really remarkable, I think, is how this sequence connects different mathematical worlds. We're talking integer partitions, sure, but also the geometry of 3D structures. It shows they share the same underlying rules. So our goal today is to unpack that, look at the combinatorial meanings and the math behind it.
Okay, so how does a string of numbers like 1, 1, 4, 10 pack such a punch? Where do we start? The core identity, the sources say, is the expansion of GF product 1, 1, xk plus 1, 2. That looks pretty intense.
It does look like a mouthful, yeah.
Yeah.
But think of that generating function, the GF, as a kind of master recipe. It's not just symbols. It encodes everything about the sequence, all the rules for generating every term. And that specific exponent, kk plus 1, 2, that's the key. It sets up the unique way we're going to count things.
Right, the rules encoded in the formula. So how do these rules play out with the actual numbers? One interpretation mentioned is that it's the number of partitions of n if there are kk plus 1, 2 kinds of k. That's different.
Exactly. It expands the idea of a partition. Normally, partitioning 3 gives you just 3, 2 plus 1, 1 plus 1 plus 1, 3 ways. But here, each number k isn't just itself. It has kk plus 1, 2 different, let's say, flavors or kinds. So the number 3 doesn't just represent 3. There are actually 3 plus 1, 2 equals 6 distinct kinds of 3 you can use.
Oh, I see. So that dramatically increases the possibility.
Precisely.
Yeah.
And that's why A3 isn't 3, it jumps to 10.
Yeah.
You're counting combinations of these different kinds under these specific weighted rules.
Okay, that's one angle. But what's really fascinating is the other interpretation. It says this same sequence counts the number of solid partitions of corner hook volume n. Solid partitions. That feels like a completely different concept. We're going from abstract kinds of numbers to, 3D shapes.
It is astonishing, isn't it? A solid partition is basically stacking blocks in 3 dimensions. Think Legos. But arranged in a very ordered, non-increasing way along axes. And corner hook volume is a specific way to measure the size or content of these 3D arrangements, often related to their structure around a corner.
And the number of those structures matches the number of these kinds partitions.
Exactly the same sequence, A000294. It counts both. It points to this deep mathematical equivalence and isomorphism between these seemingly unrelated concepts, like the universe using the same counting logic for different things. For example, A2 is 1, just one solid partition 2 with that volume, but A3 is 4. You get 3 distinct solid partitions made of 2 ones arranged differently in space, plus one solid partition that's just a single block of size 3. It offers these really rich different views.
That connection is genuinely mind-bending. Okay, so we see what it counts, these combinatorial things. What about the pure math driving it?
Right, the machinery. Beyond counting, the sequence follows a recurrence relation. The sources give one like A and sigma 2k plus sigma 3k and a k. That gives us a way to actually compute the terms. But maybe more profound are the asymptotic formulas.
Asymptotic, you mean how it behaves for really large numbers?
Yes. These formulas involve some pretty advanced constants, like the Glaisher Kinkelin constant and Riemann zeta function value zeta 3. These aren't just abstract names. They tell us about the sequence's deep analytical structure, its growth rate. It hints at its fundamental nature within number theory.
And for anyone listening who wants to, play around with this themselves, the good news is it's quite accessible. You can compute it using Maple, Mathematica, Perry, Sage Math, lots of tools. So it's not just theoretical.
Definitely. It's there to be explored.
So bringing it all together, A000294 might start simply, but it's clearly a cornerstone sequence. It acts as this incredible bridge between classic partitions, these higher dimensional solid structures, and some pretty sophisticated analysis. It shows how interconnected math can be.
Absolutely. And that leads to a thought for you, the listener. I really encourage you to explore the OEIS database. Maybe start with A000294. Think about how these sequences, just lists of integers, can capture such complex beauty through definitions that look completely different on the surface. What other hidden connections, other combinatorial gems are waiting in that database, linking ideas we haven't even thought to connect yet. It's quite a rabbit hole. There's always more.